Welcome back to another episode of Tech Talk Today, where we dive into the fascinating world of programming languages and technology innovations. Today, we're exploring an experimental programming language called PAR, which takes the principles of linear logic and brings them into the realm of concurrent programming. So, what exactly is PAR? Well, it's a fresh approach to concurrency that aims to provide a powerful yet intuitive experience for programmers. It operates on the idea that all values are channels. Imagine that. Instead of treating data and processes separately, PAR blurs the line, allowing everything to communicate seamlessly through channels. Picture a bustling online marketplace where every item for sale is wrapped in a conversation, ready to connect buyers and sellers in real time. Now, before you get overwhelmed, don't worry if you're not steeped in logic or advanced programming. PAR is designed to be accessible. The rules sound complex, but they actually lead to a streamlined development experience. Think of it like learning to ride a bike. It might seem daunting at first, but once you get the hang of it, you'll feel empowered. One of the standout features of PAR is its avoidance of deadlocks, thanks to its channel-based structure. Each channel represents a connection between processes, ensuring that all components are always reachable. If you visualize this as a city, PAR ensures that every street connects back to the main road, preventing any neighborhood from becoming isolated. Let's talk about how you can set up PAR. If you're eager to jump in, the first step is to install Rust and Cargo, then clone the repository to access the interactive playground. Sounds simple, right? Once you're in the playground, you can start playing around with some code. Here's a little tidbit to whet your appetite. You might define a channel like so. Imagine defining a function to handle color choices. Straightforward, right? Well, PAR compiles this high-level code into a more accessible form for you, so you can focus on your logic rather than getting bogged down by syntax errors. As we dig deeper, we find that PAR uses something called process syntax. This is where things can get exciting. Process syntax lets you define the behavior of your programs while ensuring that processes can communicate effectively via signals. Much like sending a text to a friend to get their input during a debate, signaling allows different parts of your program to work together efficiently. But here's a twist. What happens when you want multiple operations to run at the same time? PAR incorporates concurrency in an astonishingly unique way. By allowing multiple branches of code to interact, it creates a fluid experience, reminiscent of chatting with multiple friends at a gathering, each contributing to the conversation in their own way. Now let's switch gears a bit and think about recursion, a concept that can make or break your programming experience. In PAR, recursion is addressed brilliantly through the begin and loop constructs. You can define a process to handle complex operations without referencing itself directly, making your code cleaner and more concise. It's like passing the baton in a relay race. You don't have to run back to the starting line to keep going. And here's where it gets even better. PAR allows linking two channels, which enables them to communicate directly. If you think about traditional languages, this is like creating a bridge between two islands to ensure smooth travel. Now, if you're wondering about practical applications, PAR's capabilities lay the groundwork for a wide variety of applications, from functional programming to building interactive web applications. The flexibility it offers reminds us that the future of programming could be about simplifying complex tasks while enhancing concurrency. As we wrap up today's episode, think about this. What if every programming language adopted principles fro